Lastly, I just wanted to thank our sponsor of tonight's panel, NL Green Power, and let Sandra Cohn, Director of Innovation, NL Green Power North America, based just up the road in Andover, say a couple words. And then he's going to actually join be part of the panel as well. Please.
Hi guys. Well, thank you all for coming, and thank you for having me, Greentown Labs. So by way of introduction, should I give the introduction to NL, I guess? It's it. Well, I mean, so thank you for coming. I mean, NL is a member of I lost my train of thought, excuse me. So NL is the largest is an Italian utility, the largest in Europe. Here in the United States, we are a renewable energy IPP. We've been here for quite a long time. So we actually came to the U.S. in 2000 when we acquired a firm called Consolidated Hydro, which was a hydroelectric IPP that managed the Lowell and Lawrence dams up here in Lowell Lawrence. We've since grown since then. We are prominent in all 5 of the conventional renewable energies. We manage about 11 gigawatts here in the United States, starting with this core hydro capacity and then expanding out to wind in the Midwest and geothermal out in the far west and PV elsewhere. So that's where we are.
And you'll hear more from Sandra in just a minute. Now I get to introduce and say thank you again. Yes, and so I'm now getting out of your way. I've spoken too long, and I'm going to hand it off to Emily Reichert, our CEO. And thanks again for coming.
Good evening, everyone. Welcome to Greentown, and welcome to our panel tonight. This is the second panel in a series on the decentralization, decarbonization, and digitalization, Katie, are you impressed I got through all that, of our energy infrastructure. The first panel on this was on microgrids back in November, and at that time we were honored to have the same wonderful moderator that we have tonight, who's Richard Stubbe, the president of Future Energy Advisors. So thanks, Richard, in advance for the wonderful panel you're about to moderate. Tonight, of course, our subject is beyond the battery, the software side of energy storage. And you may be wondering why at Greentown Labs we are talking about software, because of course we are a hardware-focused incubator. But most in the audience here tonight will already know that energy storage is a critical element of the modern grid. But how do you make this happen? The software behind it will actually ensure that it can operate, integrate, and manage complex electricity demands on an ever more complex system. And it turns out we have several companies who are already working in this space, from Sparkplug Power, who's already been mentioned, to NewGrid, to Hela, who's one of our newest members. So Greentown Labs is a place where this innovation is already happening and where we expect it will continue to happen. So that's why tonight's panel's here. Our panelists tonight also represent innovators in this space, and I'd also like to give a small shout out to NL Green Power, who's tonight's sponsor. Thank you.
Thanks, Emily. So without further ado, I'm going to invite the panelists to come sit up front. And while they do, if you want to give them a warm round of applause, that'd be great. So my name's Katie, and I work for Greentown Labs, and I have the honor of introducing Richard Stubbe, your moderator this evening. Richard is a 30-year veteran of the electricity power sector. He's the president of Future Energy Advisors, a management consulting practice providing advisory services to corporate clients pursuing innovative growth strategies related to energy, which I think says a lot. So without further ado, I'm going to turn it over to Richard.
All right, thank you. Well, first of all, thank you all for coming out tonight. I think we have a great panel, and I'm glad you were demonstrating your interest by voting to come here tonight, so thank you. Emily took away a lot of the comments I was going to make about energy storage, so thank you for setting that up so well. I think you were looking over my shoulder when I was typing up my notes this morning. Very few segments of the economy are getting as much attention these days as energy storage. And it's being driven by dramatically reducing costs of energy storage, which in turn is being propelled by literally billions and billions, I don't know how many billions of dollars, actually Robbie might know how many billions of dollars, maybe you can answer this question, of R&D and manufacturing scale up of batteries to enable the transition from internal combustion engines to electric vehicles for automobiles. And as those battery costs fall, more and more niches of economic opportunity emerge for energy storage in connecting to the power grid. And so as that happens, it's going to become more and more ubiquitous to the point where, I don't know if it's 5 years or 20 years, but there'll probably be more storage on the grid than there are solar panels. And actually, those two things go hand in hand because storage is a really critical enabler of the sustainability economy of the future. We're not going to get to deep decarbonization in the power sector and moving to 100% renewables without energy storage because of the intermittency issue. But energy storage also enables not only the reduction in deep decarbonization of emissions, but it also allows us to improve the resiliency and flexibility and power quality on the grid. So it's not just an environmental imperative. Energy storage actually is consistent with the increasing digitization, one of the 3 Ds that was mentioned, of the grid and the increasing need for higher power quality in the face of, frankly, a more stormy and turbulent, threat-populated world that we face. Now, almost all the attention that has been paid to energy storage, though, has been around the hardware, especially around the batteries, and their chemistries and their costs, and that's all important. But to actually make use of these devices and to capture value from them, they actually have to work well, and they have to interface with the grid and or with the automobile, however they're being utilized. There's a lot of analytical processing that needs to happen. I was always a huge fan of Jimi Hendrix, and I think that's the closest I'll ever be to his talent level. But so as a result of the imperative of energy of the software aspect of storage, there's actually an amazing amount of activity going on in software development associated with storage. Some of it is in-house by the major storage companies, whether they're the battery companies themselves, like LG and Samsung, and Panasonic. Thank you, Panasonic, for becoming a sponsor of Greentown, and also on the panel tonight. But also the companies that are doing the development of these projects, and also there are companies that are just solely based on software, trying to sell their services into the energy storage sector. So there's a very vibrant ecosystem that's emerging, and what we want to do with tonight's panel is begin to give you, the audience, a flavor of the challenges they're working on, the nature of that ecosystem, and where you as interested members of the community might want to dig in this very fertile ground. So, this panel, first of all, we will, while we will, ask ourselves questions, and we hope to engage in a very interactive dialogue here, the most important thing, our metric for success is if you're asking all the questions, if you're really engaged. So we want you to raise your hand and chime in when you hear something that you really want to dig into. We'll go for about an hour, and then we'll adjourn so we can network and enjoy the refreshments that our friends at NL were so happy to sponsor tonight. So another round of applause for them is well appreciated. We put together the panel to try and represent a wide variety of perspectives on the energy storage ecosystem, ranging from market observers like Ravi Mandani from GTM, through the development community, through the actual battery manufacturers themselves, and new battery technology developers. So we think we've got the waterfront covered, and we'll be able to kind of talk about energy storage software issues and needs from across the spectrum. So right now I'll introduce each of the panelists one at a time, and I'd like for each of the panelists to spend 2, 3, 4 minutes giving a sense of who you are, what you do, what your organization does, and sort of some introductory fodder for kicking the conversation off. So first, I would like to start with Ravi Mangani, who's the Director of Energy Storage at Greentech Media Research, which is arguably the leading observer of the energy storage marketplace. He's got 8 years of experience in that capacity, but he has an impressive educational background, having a Master's in International Business from Tufts and chemical engineering degrees from University of Washington in Seattle, and also from the Institute of Chemical Technology in Mumbai. So, Ravi, take it away.
Great. Thanks, Richard, and thanks to Greentown Lab for inviting me to speak here. I'm not.
Are there any, should we turn one microphone off?
Yeah, I'll use
Excellent. Great. So, Richard did give a kind of introduction, so that makes my job easier. Greentech Media, as you know, is a Boston-based market research and analysis firm, as well, information services provider, if you may. We have different ways in which we interact with the broader green tech community. We have our website, greentechmedia.com, which I hope a lot of you are members or subscribers of, as well as GTM Research, which is what I represent. And thirdly, we also have an events business where we host several events in across the country, across various topics, all the way from solar to grid technologies to storage. So I lead the market research, energy storage-based market research at GTM. And what we basically cover within GTM research on energy storage is looking at where the market's headed, right? Where is it today, where it's headed. So tracking various policy and business drivers, all the way from regulatory mechanisms to mandates, as we will have in Massachusetts, to actual, what's going on in the industry with respect to technology and advancements, cost reductions, plus business model changes as well. So in the context of today's panel, what I wanted to sort of start off with is at the very basic level, right? Batteries are dumb, and I don't mean to say that in any derogatory way, but the point is that the way a battery is structured, you have two electrodes and an electrolyte and electrical connections that go across the two electrodes. So at any given time, a battery can be sending electrons one way and the ions the other way and be discharging, or the other way around, be sending the electrons back where they came from and ions back where they came from and be charging, right? So there are a couple of things to pay attention when we talk about storage here. Is unlike a lot of the other traditional or even non-traditional assets that are on the grid, it doesn't generate, okay? So it's not a generating asset per se. But what it can do, it can act as a generator when needed by discharging, or act as a load by charging, right? And to be able to sort of do that in a efficient and optimized way, what we do need is the right kind of software. And hence we are here to talk about software and how software is enabling some of the value streams that storage can potentially provide to the grid, as well as to all the participants on the grid, all the way from the utilities to end customers like us. That's my hopefully less than 3-minute pitch.
Great, thank you so much, Ravi, and I'm glad to hear that you can leverage your chemical engineering education in the work that you do. That's terrific. Next, I'd like to introduce Mike Berlinski, who's Director of Emerging Technologies and Customized Energy Solutions. Customized Energy Solutions is one of the leading professional services and consulting firms supporting the energy storage sector. Mike assists clients on a variety of energy storage related topics and have a lot of experience actually bringing energy storage projects online, which not many people actually have that experience onto their belt. So that's actually, I'm sure he's got some very interesting anecdotes to bring forth from that experience. You've also been involved in energy project development and energy consulting in a variety of capacities. You have a master's in technology and policy from MIT. Now, when I was at MIT, every every program had a number associated with it. I don't know if that one does.
It does not.
Yeah, so it almost doesn't count.
Which makes
as far
it
as
very
I'm
hard to answer the question,
concerned.
what number,
Yeah.
and the answer was ESD, and letters just don't fly at
Yeah,
my
it's kind of and before that, physics at Wesleyan University. So obviously, as we have a rocket scientist here, so with that, take it away, Mike.
Thank you. The once and former rocket scientist. So I'm a director of emerging technologies at Customized Energy Solutions (CES). As Richard said, we're a consulting firm. So we develop hosted software solutions, and we provide a range of services to our clients. We develop a lot of software solutions ourselves. We have a lot of web-based portals where customers can access data or do analysis. We run a lot of models to do analysis to provide insight to clients, help them design a battery or determine the financial returns for a project. In my group, we really focus on energy storage, and our clients span the range of technology developers, project developers, and utilities. Another thing that my company does is a lot of services for the industry. So we have a 24/7 operations center, and we use some more of the conventional software though to schedule and dispatch resources into the markets. We cover all of the U.S. and Canada and India. We focus on electricity and natural gas and the wholesale and retail markets. And for me, for energy storage software, I see it as two buckets. So that's my framework. Is one side is the analysis, and the other side is the operations. So that's sort of how I'm coming to tonight's topic. Thank you.
So I always say there's two types of people in the world. One who divides the world into two types, and those who don't. So obviously you do that. Next, I'd like to introduce Mike Hess, who is Vice President of Smart and Sustainable Buildings from the new sponsor, Panasonic. One of the interesting things about his role is that he is responsible for the teams that are doing a lot of the smart city and smart building activities for Panasonic, including they're developing a very cutting-edge headquarters facility in Denver, which is nested within a microgrid and also includes energy storage. So, Mike.
Thank you. Can you guys hear me without this microphone? This thing? No. Yes. Yes. No. All right. So anyway, Mike Hess. I work for Panasonic. I lead up our smart and sustainable building team within our enterprise solutions division. What I do and what my team does is we provide upfront sustainability and energy consulting for cities, large developments, and buildings. And then if it works out, we'll actually provide turnkey solutions associated with that upfront analysis. I am also housed within what's called our City Now Smart City team, which is trying to create smart cities all over the world. And one of our business development tools is that we'll actually invest in the real estate. So part of my job is also to help look at our real estate acquisitions where we want to invest to help drive smart buildings, smart cities. And then last but not least, my personal role is really analyzing startup companies and other technology companies on the smart building side, trying to find the best in class, and then either look at do we want to invest or partner with them. And so actually one great example is Crowd Comfort, who's on the wall back here. I don't know if anyone from Crowd Comfort is here, but they're a company that we're actually testing in Denver right now and hoping to have a greater partnership with at some point. So Panasonic's role in the energy storage space, I think we're the biggest manufacturer of lithium-ion cells in the world. Is that? So we make a lot of lithium-ion cells, which he just said batteries are dumb, so that destroyed my ego for the night. Thank you. But I guess we're a little bit hidden in that market. Has anyone heard of the Tesla Gigafactory? So Panasonic actually takes up most of that building, and we're manufacturing the cells, and then Tesla assembles them into Powerwall and Model 3 battery packs. Panasonic has also made a big play into the smart city space, and energy storage is a huge part of that. And The first foray into that is a development called Fujisawa Smart and Sustainable Town. You can Google that. In Fujisawa, it's actually built, it's there. Every home has its own battery, every home has its own PV, every home has its own energy management system that rivals commercial energy management systems that we see in the US. So you actually live in a home that if there's a natural disaster, you can go off the grid, you can maintain your energy efficiency, check your battery, and stay online. And because Fujisawa was so successful, we started a smart city team here in the US, which we call City Now. And our first project to really roll out our smart city team is a project called Peña Station Next in Denver, which is partially open. Our building is built there. The train station is there. We are on it's a 400-acre mixed-use development. We are on our own microgrid that we built in partnership with utility XL Energy. Our PV just went online. We've got roughly 2 megawatts. And our initial battery just went online. We've got about 2 megawatt hours of battery storage. And so we are actually working with XL Energy and NREL right now to continue to master plan the entire 400 acres to be carbon neutral and help XL and other utilities figure out what's their business play when it comes to storage, what's the financial model, and then working with NREL to figure out what are the design tools that we need to invent to design these type of developments.
Great, thanks, Mike. Next, I'd like to introduce Sander, who's already stepped up earlier. Sander Cohen, who's the Director of Innovation at NL Green Power. He's already introduced NL Green Power. His team is responsible for testing out new technologies and business models on behalf of NL Green Power. And I really want him to talk, I'm sure he will, talk about NL Green Power's recent acquisition of a company called Demand Energy, which is squarely in the space of what we're talking about today. Before working at NL Green Power, he is also a consultant at ESAI and KEMA, and has a master's degree in international finance and energy policy from Johns Hopkins, and I didn't know this, bachelor's degree in history in U.S. and Chinese history, is that right? From Columbia, so
no numbers from me. All the numbers I learned professionally as part of my graduate degree. But we need more history majors, more expansive thinking. But you took the first half of my spiel, so we'll try it again. So I head up the innovation team for North America for NL Green Power. As I mentioned before, NL Green Power is the renewable energy group of the Italian utility Enel. Here in the U.S., it is our primary presence here with 3 gigawatts of capacity here. And as you mentioned, Richard, my group is responsible for new ideas, new technologies, new business models within the company. So looking at conventional renewables and seeing where we can go from there. And you really sort of look at it from a few different perspectives, more than 2. The first is an open innovation concept. So we deeply subscribe to the vision that we don't have all the answers, that good ideas can come from anywhere. They can come from inside the company, and they especially come from places like Greentown Laboratories. So, lots of my job, as with other folks up here, is to look out to the marketplace and put NL forth as an industrial partner, as somebody who will work with emerging technologies and emerging companies and help build them into commercial scale technologies. What we look for is also pretty broad. It falls into 3 buckets, not 2. The first is anything that expands the ability of a renewable energy resource to capture that resource. The second is anything that lowers cost of a renewable energy, of a resource. And the third is something that opens us up to a new market. And the interesting thing about energy storage is that it does all 3. And so our interest in energy storage is quite profound. I have as part of my group is mostly organized around technology lines. I'm actually one of the rare people on my team that's organized on a geographic basis. But we have a team devoted towards the commercialization and development of energy storage. Starting from things as basic as residential energy storage as part of a home management system. We have that operating with customers in South Africa, through to behind the meter storage, which I'll come back to the integration of renewables and energy storage to improve the production of a renewable energy facility, to ultimately stand alone in front of the meter energy storage as part of a grid services offering. We have some facilities in operation in Europe. We have 2 wind plus storage facilities in Europe and a solar plus storage facility in Europe. Here in the U.S., our main storage presence is what came with our acquisition of Demand Energy, and I've been working with teams to build our first presence here, first NL presence of energy storage. It's been an interesting thing. So we've been working on energy storage projects for my entire time at NL, so just about 5 years now since the foundation of the innovation group. It was one of the first innovative business opportunity units. And we first started by looking at chemistries and looking at suppliers, and exactly what Robin and Mike and all these guys were saying here. And we're at the stage where we're pretty comfortable with conventional lithium formulations, and we're looking at other advanced formulations, and we'll talk about that. I know Dana's here, so she'll talk about that. But what's interesting is that as we've gotten into the weeds of developing projects, the battery technology has been very interesting and posed its own set of challenges, but the actual development of the project and the integration of the project has proven in the balance of plants and all the other sort of, the universe around the head that is the battery storage facility has proven quite a challenge. And our acquisition of Demand Energy Networks, which we closed in January, has been our foray into understanding the integration component and realizing that in addition to battery technology, we needed a software technology along with it. So Demand Energy builds a very strong piece of software that coordinates and integrates behind the meter components, including energy storage. And they have a very large presence in New York City, and we hope to leverage them into other parts of the U.S. as we can help them grow and expand.
Great, thanks. There's a lot to dig into there, and we will. And now I'd like to introduce Dana Guernsey. Dana is from Ambri, a local earlier stage battery technology company developing a liquid metal battery technology out of MIT. She's head of corporate development there. Before Ambri, she was at Enernoc, which I'm sure is a company that many of you know here from the Boston area, a very path-breaking company and software for demand management, which a lot of the energy storage opportunities relate to. Before starting at Enernoc, Dana has a trifecta. She earned 3 degrees from Dartmouth, a master's in engineering, bachelor of engineering, bachelor's of arts, so that's pretty impressive. And so, Dana, tell us a little bit. So, I thought it was interesting to have someone from a very well-established, large manufacturer of batteries like Panasonic, as well as someone who's developing a new chemistry, a new battery technology, and can probably talk about fairly different challenges and issues associated with software. So, Dana, introduce the company.
So thank you. So thanks everyone here also for spending your evening talking about energy storage with us. So as mentioned, I too make dumb batteries. And so Ambri is a Massachusetts-based startup company for commercializing the liquid metal battery, which was invented at MIT. And what makes our battery really unique is that we're the only company in the world working on this technology. And we boast very long lifespan, low cost, and a high degree of safety. So Amber's a really exciting group of folks here, and we are a hardware company. So we also feel very at home at Greentown Labs. And when I first got the call to come talk on this panel, I actually thought that there must be a mistake because we are a hardware company. But then I started thinking about what software and storage means. And at first, you gravitate towards thinking about all of the revenue stacking applications and the ways that you can optimize the battery. But it's really more than that. There's everything from making a dumb battery a little bit smarter so that it can function as a battery system. So that's typically the battery management system. And then you have to use software to convert it into AC energy that can then be distributed across the grid. And as you go up to this more systems level thinking, at every step along the way, software is involved. And it's also involved in the sense of who is the software for, which customer is the software serving. So it can get really complicated really quickly. And I was excited to join the panel and provide everybody's perspectives as a result.
Terrific. Thank you, Dana, and thank you all of you for agreeing to be here tonight and for your eloquent introductions. So, as I said at the outset, if you have any questions at any point, raise your hand. We'll get into it. I'll have a few questions to see the discussion, but you can take it wherever you want to go with your questions. I think a good kickoff question that I'd like for any and all of the panelists to chime in on is, from your perch, and then put together a panel from a variety of different perspectives here, what is the most significant trend that's currently shaping the development of the energy storage marketplace as it relates to what software can do? Who wants to go first?
I'll start. I'll start with maybe a segment of the market as I see it, and then maybe a list of companies that you may have heard of that I associate with that segment. So behind the meter customer bill management applications is where there have been a lot of storage companies, but people might describe them as software companies using storage to provide value to customers and to reduce retail bills. So in the commercial industrial space, companies like Demand Energy, STEM, Jelly, Greensmith are those that I see where the software is really integral to the services provided, and that it includes both the analysis, we're making the business case to the customer, and then operating the system, dispatching the system, and having that intelligence of when should I operate the battery or the storage resource, and how should I be charging or discharging on a moment-to-moment basis. So that's sort of a trend in terms of identification of value and deployment of resources in that space.
So to continue on what Mike said, I guess in terms of what trend we are observing in the market is on the behind the meter side, as he said, it's predominantly electricity bill management. And we can pretty much extend that to all three segments: residential, non-residential, as well as the front of the meter segment. And you can sort of hone on to a single application that is driving the market today. On the utility side, a few years back, it was PJM driving frequency regulation-based deployments. Mike has worked on a lot of them. In the last few months, it's been local capacity requirements that are being met by storage in California. Again, on the front of the meter side, when we shift to behind the meter, it's been demand charge management for C&I customers or bill management. For residential customers, so far it's predominantly been basically the comfort of having a backup. Anyone who tells you there is an economic case for residential storage today in the US, I think that person is either living in Hawaii or is not correct. Anyways, but the point is that the trend that we expect to evolve out of these sort of initial beachhead markets and applications is that the market is going to get more diverse. We'll start to see more applications that are more complex than. I'm not saying that responding to a regulation signal in PJM is any easy. Ask again developers and operators of these systems. But the point is that at least there is a single signal to respond to. Now we are expecting that with the market growing, and as I think we already talked about this concept of multiple applications or value stacking, you are going to be stacking values. At the same time, you are going to get into the situation where there won't be a single dominant beneficiary of that asset. So there are going to be multiple beneficiaries. It could be the grid, it could be the utilities, it could be the system operator, it could be the asset owner, it could be the tenant who lives in that building. So there are, along with looking at value stacking, there is also going to be this notion of who that value goes to, right? Who monetizes that value? So into all of these, the different sort of complications, I think the role of software is going to be super critical. And I think that's the trend that we expect to see in the coming years.
If I could, Mike, I was hoping to have it go to you if you could. From a perspective of smart buildings and smart cities, what kind of software issues or topics or challenges are you seeing as being central?
So he was absolutely correct at the beginning when he said that the battery is relatively dumb. So we're focused on the software on both the production side and on the building side. So I'll start with the building side. I mean, the demand response that we see in buildings today is not extremely smart. We get a signal from the utility, or they may turn a couple of large items off, but it's not nearly as, I guess, granular as it could be. So we're actually looking at a lot of software technologies to shed even more load inside a building at a much more granular level. And it may not seem like a lot, but if we can start to trim 2%, 3% more in every building in a large-scale development, it can make a huge impact on how big the battery is. And trust me, we just installed a 2 megawatt hour battery. The thing is huge. It's as big as a semi-trailer, and it's really expensive. So if I can use software to trim a little bit of energy and make that battery smaller, it goes a long way. The other piece is on the production side. So, I mean, some of the things we're looking at are, weather sensing on the streetlights, weather sensing on airplanes, and really trying to better predict what our production is going to be. And then it's really lining up what's the production, what's the battery charge state, and how can we trim consumption in all the buildings. And then really the biggest challenge I guess I've seen on that software play is, so in our neighborhood in Denver, the battery is owned by the utility. Normally, the utility does not want you to see what's going on with their grid, but in our case, they let us. So we see the data from their battery probably faster than they do. And so we're at a much more granular level doing demand response based on what we see from the battery and based on where we think the renewable energy is going to go. And so it'll be, to me, that'll be, what's that software interface, depending on what economic model you take. Does the utility own the battery, or does the customer own the battery? That's going to drive it a little bit, and then once you figure that out, how does the software really interact between the production battery charge state and the building?
Before you hand the mic off, if you could just follow-up question, what's the role of predictive analytics and kind of accumulation of data to figure out or to anticipate what the production is going to be and what the needs are going to be, and then making some informed and educated decisions that maybe get heuristically adapted over time?
Short answer is huge. I mean, in Denver, we just built an entire network operations center that is doing exactly that. It's a huge room with screens all over the place, trying to look at where we think the production is going, looking at what our building is doing, and then as our neighborhood is fully built out, we're going to be looking at all the buildings in our 400-acre neighborhood.
So kind of illustrating, I think, the wide variety of needs in the space, turning down to Dana, it is for a firm that is developing a new hardware technology, what areas are you looking out into the marketplace for, or doing in-house because you're not finding it, saying, how can software help us do better in either producing or developing your new technology?
So when it comes to software and the build versus buy versus partner, we are building what is going to be unique to our battery, which is our battery management system. But then when we look to bring a commercial project online, we're very much at this phase anyway, looking to partner with companies who can provide that software intelligence layer. And so what we would look for is a company that can somehow bring together all of the complexities. For a dumb battery, it's really quite complicated to make it work right. And so a software that can somehow make that easier and make that simpler for the customer and balance the simplicity with the optimizing that goes on is going to be what we're looking for. And then, of course, economics. So we want a software that's going to squeeze as much economic value out of the project as possible. But just to give you a sense of why I say it is so complicated, it's everything from, first of all, what are you optimizing for? So understanding, is it behind the meter or in front of the meter? Let's say it's behind the meter, then you have to understand the customer's tariff, the customer's desires in terms of why they're using the battery and what their goals are. And so being able to pull that all together is not an easy thing to do for a software platform. And for software companies, I think the challenge is to be able to do that and then do it in Massachusetts, and then do it in Hawaii, and then do it for one type of battery and another type of battery, and then in front of the meter or behind the meter. There's just, when you get all those permutations together, it does become really complex, and the answer is always, it depends, whenever someone asks about a specific product.
From a product and technology development standpoint, are the issues around managing cell or battery module charge discharge, rate of charge discharge, depth of discharge, are Are those issues and algorithms, reasonably well developed, or is there still a lot of innovation and improvement that could be done there?
So my understanding, and you guys correct me if I'm wrong, is that it's reasonably well developed, but it's very specific to technology. So what would work for Ambry is not going to work for a lithium-ion system, is not going to work for a flow system, and even within those broad categories, there are going to be even more nuances still. And then you layer on, a lot of companies are now providing warranty agreements that have specific boundaries that you need to make sure you're operating within to make sure that you're within that warranty, and that's another layer of complexity. So I think the challenge for software developers is how do you build that software that's flexible and nimble enough to continue to accommodate all of these needs.
Sandra, I saw you mentioned from Mike, and I'd love to get your perspective.
Well, sure. I mean, I think to build on Dana's points, there's, it sounds obvious when you say it out loud, but when we talk about the software problem of batteries, right? It's not just one monolithic piece of software. It's actually the collaboration of several different pieces of software on top of several different pieces of hardware, on top of applications and geography. And so, when we talk amongst ourselves, when we talk with our management about this, we have to sort of emphasize the point that that this is a mosaic problem, right? This is that you have one piece of software and then sort of you build it from there, and this one piece of software has to communicate with another piece of software. It has to communicate with the weather prediction system, and then it also has to work back with your NOC and the communications protocol that you've established. So it's not an easy nut to crack. And part of the challenges we've been facing, we've been working on, is trying to map affinities. So the tendency from a developer standpoint is to think of this a lot like the solar market, but it's not. It's the solar market if only certain panels only work with certain inverters, and then and it's not so simple to get them to talk to each other in the end. And so that's the largest challenge we've been thinking is this sort of the mental mind shift to thinking more along software terms.
Yeah, I was actually going to make that point and I forgot to, which is that a lot of people think there's a lot of parallels to the solar market, which there are some, but the storage market, I think, has an immense amount greater complexity in terms of stochastics and probabilities, and then all the optionality that's associated with that, and therefore all the predictive analytics associated with that. To your point about all the various pieces, parts of software that need to be developed, and the challenge of having them communicate with each other and so on, does that do the large software players, whether that's SAP, Oracle, IBM, Accenture, that type of thing, are they positioning themselves to make kind of complete solution offerings to customers to cover that whole waterfront, or is it and is that the path to success, or is it going to be more likely to be successful to get specialized developers in certain niches and have standards communications protocols that allow them to talk to each other? How do you see that evolving? Maybe Sandra, since you opened that, but obviously, well, you opened it, but if you want to pass it off to anyone else, Robbie might have a perspective on that. Looks like Mike's nodding his head. So anyone who wants to talk.
I'll give it a shot. I'll give it a short answer, and I'm sure Mike and Robbie, can see the whole picture more than I can from my very narrow view. It's one of those things where this market has been so small for so long. It's one of those things where it has been niche software for a very long time. I mean, so Demand Energy has been around since 2008. They've been doing this with lead-acid batteries for quite a while, and they've been developing the software as it's sort of emerging. And then as equipment costs have come down, and as the peakiness of electricity rates has increased, the customer bill management market has become more and more apparent. And so this has created, I think, in my view, a sort of where we are right now is a really heterogeneous market where you have a lot of sort of software providers who are capturing market opportunities as they've emerged. So you have the Greensmiths of the world, for example, who built a pretty neat battery management software. You have the Demand Energies. You have the Enernox to even Enernox success. Full stop. And what we're seeing now, and what I'm seeing now, is the larger players coming to fore. So the larger players, the Siemenses, the ABBs, the IBMs of the world, sort of coming out with product offerings and they're playing catch up. So we're in an interesting space where I think a lot of the stuff where the bigger players are trying to decide whether to buy or build themselves, and whether or not they can use their sort of market presence to capture some additional territory.
I'll just pause here on the way down the line. I think I sort of, my first thought on this question was, again, in bimodal in terms of the larger companies and the startups, and are we talking about selling a product or providing a service? And so again, that's the framework that I'm thinking about, the companies that I'm familiar with, and the business models that they've made, and the projects that their names are associated with. Because some of the larger companies have divisions that are just trying to sell a product, sell some hardware, but they also have divisions that are providing other services, either consulting or integration services. And then similarly on the startup side, what is that startup providing? And even here, there's and other in the geography, local geography, there's startups providing different services or things to their future clients. So again, that's my framework.
I'll just pass it on to Smart.
But I don't really passing it on, but I'll give it a shot. So I think the market today, let's step back, right? We are not talking about a multi-billion market as yet. If you just look at the US market, which probably is the largest storage market in the world, probably, is about $500 million. So it's not big enough to for the likes of IBM or some of the other bigger sort of big fish to start getting interested in storage. Now, of course, companies like ABB and Siemens and GE and others are getting interested in it, but the commonality there is those companies also have some hardware to sell, or some other business opportunity that they see along with storage. So I think the need for rather the sort of strategy there that these companies are applying is not just look at storage in isolation, but to Mike's point, like he's working in a smart city group. So storage becomes a component of the smart city group, and hence probably he's interested in storage. So I think we're still a few years out from some of the other non-adjacent players getting interested, non-adjacent larger players getting interested in storage software.
Yeah, you nailed it again. No, he's exactly right. So I've seen small companies and big companies that could easily do the software, that could figure it out. I mean, on our end, we're investing in it, and we're building our own platform because it's part of a bigger play. So we're building a smart city IoT dashboard that has the production, it has the storage, it has the demand response within the building, it has trash management, it's looking at the security cameras on the streetlights, it's looking at the autonomous vehicles driving through our neighborhood. So it's a platform that's looking at all of those things. And for us, that makes it something we really want to tackle because we can apply that in more places.
So we want to wrap up probably in about 5 or 10 minutes. Are there any questions from the audience? I have a few more, but if there are any questions from the audience, that would be a good time. Yep.
So as you said before,
Speak up.
yeah, absolutely. So all of the installations of battery storage up into this point, like you said, there's kind of a primary value proposition of frequency regulation, and PJM is a good example. So where is the real bottleneck to implementing optimization, the stack of the value in a meaningful way? Is the bottleneck that the software applications haven't been developed to the point where they can be used across enough platforms, or is it more ISO rules and market mechanisms that are holding back the multi-value stacking? Because, for example, like in PJM, back in the heyday when they were installing those projects, the price for frequency regulation was at $45. Now it's at $15. So it's to meaningfully integrate battery storage and to have battery systems have bankability behind them, they need those diversification of value streams. So where's that bottleneck really?
Who wants that one?
I'll start, and I would I think that's a great question. I would take this opportunity to point everyone to the Massachusetts State of Charge report that the CDC and DOER released, because I think that's a really good documentation of this challenge in particular. I think it does a really good benefit analysis and it really explains that there is a challenge to monetizing the benefits of storage. And so one of the barriers is that storage can provide a lot of services, a lot of value, but owners and other related parties can't necessarily make a buck on it, and that's a challenge. And that value that really depends on who the owner is, who the client is. And so I would say a lot of value is not monetizable, and so that is a challenge to stacking services where you can make money on, but also there are regulatory barriers that it gets into in Massachusetts, in New England, and all over the country and other jurisdictions as well.
And when it comes to regulatory barriers, it's not always that storage is specifically not allowed to participate in a specific market, but that it's almost an identity crisis and an ownership issue, because the person or company who owns the storage might not have access to all of those value streams, and so it becomes almost a shared need to access all those value streams. So, for example, if a battery is behind the meter at a customer site, that customer might have value out of reducing their demand charges, but also their local utility might have value out of helping with the distribution network, but there's no obvious way for those two parties to share in that. And so it is a very large, I think, regulatory challenge.
So my perspective is from the utility perspective, because that's really where we're focusing. And the utilities we're working with don't understand how to quantify the value yet. They don't understand what can I charge for this to be able to pay back for this battery that I just put in. So that's actually something we're working with several utilities to try to figure out. And then the other side of that is, what is the customer really willing to pay? So is it worth it? You know, do you really want to live in a neighborhood that's carbon neutral, and are you willing to pay an extra penny a kilowatt hour or whatever the value is for that? Or do you really care about resiliency, and are you willing to pay a little bit extra on your bill, knowing that if a storm comes through, that your power is going to stay online because you're on a microgrid with battery storage? And so that's actually something we're working on with our utility customers and helping them quantify that, and eventually going forward before the Public Utilities Commissions to argue that there's a different rate structure that has to go with utility scale battery storage and renewable energy that is clean energy and resilient, more so than the rest of the grid.
If I may sort of add another layer on that, we talked about sort of regulatory barriers as they apply to ISOs, but similar barriers also apply to utilities, right? The fact that it's still not clear whether utilities are allowed to own storage assets, and if they're allowed to own storage assets, should they be cost recovered or should they be merchant projects? The Excel project that Mike talked about, in fact, is part of a pilot project that the Colorado Public Utility Commission approved. So hence they were able to go forward with such a project. So again, it comes back to I believe regulatory hurdles are probably the biggest bottleneck today. But again, I don't want to sort of let the battery vendors and the industry itself get off the hook. So they need to sort of establish some sort of best practices and show that these systems can last as long as they commit these systems to last and provide the same amount of value as sort of contracted in some of the projects. So yeah, I think there are multiple, but it's a multi-layered sort of issue.
Did I see a question back there? Yeah.
So first, thank you all for coming. It's really cool. And I've been doing web and software stuff for a long time, and to hear you guys talk about build versus buy, customization and integration, analysis and optimization, it's all old school stuff. So I'm glad I'm going to be employed for a long time. The question I had, and I think you touched on it. It sounds like a lot of the software is actually back-end analysis, optimized, economic business focus. Is there a component to it that's more user-based, and maybe on the smart village side, people talking about IoT and talking about the way people manage their households, the way they manage their day. Is that part of the conversation at all, or is it really the bulk of the work really being done on the business side?
Sandra, do you want to start?
The short answer is yeah, for sure. I think that we've been talking a lot about sort of the back end, the hardware integration side, but a lot of this is also creating the prosumer, right? So communicating the information and the metrics forward to maybe not necessarily the consumer, like my mom, who wants to turn on the light and the light turns on, but maybe a building manager, right? So who wants to be able to understand and easily consume metrics and understand where the loads are and have a role in sort of managing those loads. So for example, if you're a building manager and you get a call for a demand response incident or demand response call, and you want to switch off your grid, we want to have control over understanding, when you want to turn off those loads, how you want to turn off those loads, and how you want to respond to your because you know your customer best and you know your home best. So I think there is a separate suite of software here that communicates information to the consumer, and I think Mike probably thinks about this quite a bit.
Yeah, I mean, the interface is critical. Most buildings you walk into are not operating anywhere near where they could be. And a lot of that has to do with the communication and the interface within a building. I mean, people just don't understand it, or the right people aren't seeing it. So it's a critical piece.
Yeah. So I think about some of the points that were made. I can speak loud. Some of the points that were made about adoption rates of solar over the last 10 years, behind the meter being a huge driver based on demand tariffs and things along those lines. But clearly, other than the coasts, we're not seeing demand charges that really help to make the economy work. What's going to be the driver of economy of scale? Is it just manufacturing due to the EV production that you guys were able to move with Tesla, moving from the 18650 to the new 2170 size cell? Or what's going to be the driver of adoption in these markets that don't have the big enough demand charges to have a lot of the pure play value, the economics? I'm buying this because I've got a 3-year ROI. What do you guys think is going to be the driver?
Yeah, I'll start from one perspective. 4 letters, FERC, FERC, so the Federal Energy Regulatory Commission, has a proposal to reduce barriers and enable full market participation for electric storage resources in the organized wholesale market, so the ISO markets, which covers a good part of the country, but not all the country. And that has been, as we talked about, PJM, has been a market for energy storage, both front of the meter and behind the meter. So that is sort of market potential that can be unlocked with one ruling from that commission once they get a quorum of commissioners. I'll pause there and turn it over maybe to some of my colleagues to talk about other market segments and other sort of potential out there, but that's sort of top of mind for me.
Mike basically sort of mentioned the 4 letters that I was going to use. But the other component that NOPR is also not just storage, but sort of to emphasize more on that, it asks for removing barriers for all distributed energy resources to participate in the ISO market. That's number one. So keep an eye on that until the commissioners are in their office. The other way in which we think that storage, behind the meter storage, will be able to participate in markets where demand charges are not inherently high is maybe not necessarily through ISO opportunities, but utilities are everywhere, right? In regulated and deregulated markets, but especially in regulated markets where there aren't any ISOs to speak of, are still in need of investments. They are still in need of building substations or upgrading substations. So I think there is a role for behind-the-meter storage to play in providing deferral services and other grid services to provide frequency response, because again, frequency response is an issue in all wherever there is electricity, right? So storage can provide some of those services, which again today are not monetizable, but can be with the right kind of rules and regulations. And the last component that I'm going to add again is solar, right? I think we are in a net energy metering paradigm today, but aren't going to be in that paradigm for forever. So as utility tariff structures move away from full retail rate net energy metering, as we've already seen in Arizona and Nevada, which are again not coasts, but markets where solar export would be priced at a lower tariff, less than retail rate tariff point. You could see value for energy arbitrage and solar paired storage opportunities.
I think Robbie brings a really good point there, which is, you know, when we've been talking a lot about behind the meter storage and sort of microgrid and C&I, but you know, when we look at our utility scale plants, you know, we are pushing forward as you know, renewables plus storage as a full commercial opportunity. That's something that has actually moved out of innovations bucket and has now moved into our BD group. Whether or not they do anything with it is totally up to them, but they are now, you know, under instruction to evaluate storage as an option when they're building utility scale plants, specifically for that reason, where you're trying to make the most of sometimes a diminishing PPA environment or a changing PPA environment, especially either with either utility PPAs or private offtake PPAs. And so both of those are starting to have more to them than just build a plant, produce energy, make money, but it's actually build plants, produce energy at specific times and specific periods during the year with a certain level of reliability, and then make money. And then the money breaks down into all sorts of different directions. But storage is a huge component of that.
Last call for questions. So let's see. I'm going to have to just do 2 more questions. Yes, handmaid.
So I work in software, and I work in healthcare technology software, and right now what's happening is they're moving from everybody being focused on providers and billers and practice managers, and in all of the major EMR companies, they're realizing there's an arms race right now to get the patients. And they're all building platforms to leverage all the network effects that they can from actually having the patients be users on the platforms. So the question that I have is, you know, you said, okay, well, the user's not going to be my mom, but when you think about the technology of energy that your kids are going to be using, what that's going to mean for how they interact with energy, what do you see as the vision for the, you know, what's going to be the thing that breaks through, that becomes the Apple of energy technology for the consumer side?
I think that's really a great question. I'd like all the panelists to answer and use that as the wrap-up question. It's just too good to not have be the last question.
Can I get extra points if I connect it to energy storage?
Yeah.
You know, I think that's looking down the line and NL's broader strategy. We've been thinking a lot about that. And when you look at it, it's really full digitization of energy. So you're looking at things like peer-to-peer energy transactions, where, for example, if you have a solar panel on your roof and you're not using the full capacity of solar panel on the roof, having the utility facilitate the direct sale of kilowatts from your house to kilowatts to your neighbor's house, and have that be handled through a secure transaction. I'm trying not to mention blockchains. It's so buzzy, but yes, blockchain. You know, via a blockchain transaction, yes. But that requires a really fundamental rethinking of how a utility operates, and more of this goes back to batteries in the sense that you're talking more about electrons and delivering electrons as a service rather than as a generation. So you're not necessarily being an electron factory anymore, but you're moving electrons from place to place. And where energy storage comes into this, becomes a time value question. Is the electron I'm producing today valuable right now, or is it more valuable to someone else, or is it more valuable tomorrow, you know, further and further on down the road? And so when you look at that question, it really becomes much more of, you know, being able to deliver the electron to the person who values it the most. And that is, it is less about generation and less about kilowatts and more about understanding supply and demand on a really innate level.
Great, thanks. I'll reference 2 of my fellow panelists in my answer. First, Robbie, who said that the economics of residential energy storage are not great, not there. And I would say in the Massachusetts State of Charge report, the use case of residential energy storage was the one that was not cost effective. So I'd say it's not really there yet today where it's economic to have a lot of individual residential consumers interacting with the grid that way. But the other part of that is the future. And I'll turn to companies in New York and what the New York Public Service Commission has been doing with the Reforming Energy Vision, REV, and that's really the vision, having a prosumer, as Sandra mentioned, where it's the individual consumer, whether it be residential or non-residential, really interacting with the grid, with the utility on a distribution system, and maybe even the ISO up to that transmission level system through devices powered by software in their places of consumption, and really interacting with all those different markets to optimize their experience, which could be comfort, it could be carbon reduction, it could be bill reduction.
So at the risk of being really controversial, I'm going to come back to your.
Go
for it. So you brought up the analogy of the healthcare industry really turning to patients, and I don't really think that will ever happen for the energy industry, because fundamentally energy is a utility and it's something that's there, but it's not your health. So when you're talking about really, in the future, let's just say that it is economic for residential users. I still don't really think we're going to struggle to get those end users really engaged in the way that they might if they're talking about a platform for their health. I think that in my best case scenario in the future, storage is everywhere and it's boring. The way that a transformer is on every substation and it's boring, and we drive by it every day and we don't notice that it's there. Like, if we're successful, we won't even know. The grid won't be as peaky as it has been. It'll be flat. It'll be cheaper for everybody, and everybody's home will be connected, and they'll be looking at all their IoT stuff. But they're not really going to be looking at how many kilowatt hours their refrigerator is drawing, because the system that's running in their house is just going to reduce it for them. Like, they just want to use less energy and pay less money, and they don't really care in the same way they care about their health. Now, with that said, this is my opinion. Now, with that said, the utility companies and the people who work there and the people who are going to be running the grid, they need really kick-ass systems that they're going to interact with and use and own. And so I think that's where focusing on the patient, or really the end user, that's who I think it'll be, the power plant owners. So.
Great. I think we had this conversation. I'm going to steal some of the thoughts from one of my colleagues, not here, but my office colleagues, that when our kids are old enough, would they even own a car or have a single utility provide them energy, right? Probably not. At least on the car side, we're already seeing that today, right? We are in the world of Uber. So in that sense, the question is, what's going to be the future in terms of who's going to be the Apple of energy or Uber of energy? I guess some of the comments have already been made, so I'm going to just sort of reiterate them. That at the end of the day, the residential customer is even some of the most passionate residential customers want to take ownership of their electricity bill. I'm not going to be monitoring their electricity consumption on a minute by minute basis, right? So there has to be some level of automation, hence we come back to software. But that software doesn't have to necessarily be real time in the sense of the end customer doesn't have to be aware of it in real time. A lot of that would be still at the back end. So in that sense, a lot of the software innovation that we expect to happen would still happen in the NORGs, as well as it doesn't mean that we won't have a distributed future. We'll still have a distributed future, but the software can be at a centralized cloud location, if you may.
Yeah, I'm going to go in a little different direction and maybe disagree with you a little bit and even answer your question a little bit. I think resiliency is going to be another market driver, and I think that is very people connected. So I live in Florida. I've been through multiple hurricanes. I have this little generator, gas generator. I hate it. I got to change the oil, get gas. It's pouring outside. I got to move it around to make sure the exhaust isn't coming back in my house. It's a pain in my ass. So I think from a residential customer perspective, if my utility put a battery in my neighborhood, I would be more than willing to pay a little extra for that and get rid of my generator. From a bigger picture perspective, you mentioned healthcare. Most hospitals are on backup diesel generators. When Hurricane Charlie went through Florida back in 2004. The company I worked for at the time, we helped a ton of hospitals in Florida bring the hospital back online because they didn't do a great job at maintaining these diesel generators. And the hurricane knocked out regular power, and the hospital lost power, and it was a bit of a nightmare. If it was just a dumb battery, it would have been way easier for them to maintain, and they probably would have avoided all those problems. So I think resiliency, that feeling of safety and security, like in my office in Denver now, we have weather sensing, and I know if a windstorm's coming, I don't care. I can look at the battery charge state of the battery right next to our building, and I know we're going to be fine. It doesn't matter what happens across the street. So I think that's another piece.
Okay, well, I know there are other questions out there, but I want to make time for mingling and networking. We'll all be around to add follow-up questions. And so in closing, I'd like to make four thank yous. One is thank you to all the panelists here for participating. Thank you to NL, Green Power for sponsoring the reception. Thank you for Greentown Labs, and especially Katie McDonald for all of the help in organizing and convening this event. And most importantly, thank all of you for being here and being such an interested and engaged audience. And I would like for all of you to make a round of applause for all those four thank yous.